Okay, so we've done element symbols, right? Yesterday we used those symbols to do formulas, right? Everybody with me? And then now we're going to take our formulas and put them together to write equations. Okay? Okay. So a chemical equation is a shorthand way of describing a chemical reaction. A short way to describe a chemical reaction. This is what the equation would look like, or a sample of an equation. This is an example right here. N2 plus 3H2 yields 2NH3. I'm going to read it to you again. N2 plus 3H2 yields, that's an arrow, 2NH3. Okay? So basically, we're saying that these two things combine and make this product. They react. That would be when we get our bubbling or fizzing or a fire or any of those clues we talked about, the color change. That would happen because these two joined and made that. Everybody cool? Okay, so the left side, these two things, they're on the left side. They're called the reactants. They go through the reaction. And they make us a new product. So the right side is called the product. Did you hear what word I used for that arrow? Yield. This is called a yield sign. Or equal to. So, it's just like saying 1 plus 1 equals 2. This plus that equals that. Okay? Okay, so this follows a law. It's a law because it doesn't matter how many times we test it, we're going to always get the same result. That law is called the law of conservation of mass. Have y'all heard of that before? You have not. I bet you have. In a chemical reaction, of conservation of mass. The law of conservation of mass. In a chemical reaction, mass cannot be created nor destroyed. You never heard of that? Mass cannot be created nor destroyed. Matter cannot be created nor destroyed. Because the amount of atoms that you have are not going to change. No matter what I start with, I'm going to finish with it, but they might become something else. So you just said, how's that going to happen because something could get smaller, or isn't that how you just said it? Okay. Well, maybe I'm going to use the word lost, but it doesn't mean it disappeared. Maybe I lost some because it turned into a gas. So I have less of the solid because some of it is the solid and some of it is a gas. But it's a new solid and a new gas. Okay? Basically, what this law is telling you is the amount you start with, you will always finish with. Okay? That's a great question. So I have 200 grams of reactant, and that will equal 200 grams of product. Or if I have 400 grams, that's going to equal 400 grams. The amount that I begin with, I will always finish with. Okay? So a test question could maybe look like this. You have 50 grams of sodium, and you combine that with 100 grams of chlorine. What's your product? I told you in the beginning, it's as easy as 1 plus 1 equals 2. Don't make this hard. If I start with this, what am I going to finish with? 150 grams of, what is that? What does that make? Sodium chloride, which is salt. Yes, 150 grams of sodium chloride, and that is salt. Okay? Or maybe it would look like this. You have 25 grams of sodium, and you measure your product, and your product has 50 grams of salt. Yes, ma'am?
Can you please bring Kirsten Hay to attendance for a moment?
Sure.
Thank you.
How much chlorine was in my reactant? 25 grams. Who doesn't understand that one? Or has a question or needs me to explain further? No, just leave it. It's okay. No one? Okay. Moving on. So, the mass is the easy way to understand all this. Okay? I'll explain to you Friday how I got those grams, but this is the easy way. Okay? A little bit more difficult is if we're talking about it, reading it on how many atoms they have. So you have to use what I taught you yesterday to read this today. Okay? All right, so here's an equation. And the first thing we need to do is make sure that it fits the law. And the law tells us what we start with, we have to end with. Okay? So to check that out, we're going to count our atoms. How many oxygens do I have right here in this formula? 2. Let me do that in pink. How many magnesiums do I have right here? 1. The law says that the arrow means equal, right? And how many magnesiums right here? 1. And how many oxygens right here? 1. According to the law, the amount that I begin with, I have to end with. Is that equal right now? No. So I am not balanced. Right now, according to this, I have way too much on this side compared to this side. Who does not understand? Okay. As long as you can see that, you can do this. Don't make it hard. Okay? So, if there's 2 oxygens over here, I also have to have 2 oxygens over here. This does not mean that I'm creating matter. What it means is, if I started with 2, I ended with 2. And if we read this right now, MgO, how many MgOs is this? 1. That can't be correct. That means when I ended my reaction, I had to have 2. Okay, because this oxygen is 2, I started with 2 oxygens. I ended with magnesium oxide, but I didn't end with only 1. I actually ended with 2. Okay? So the black writing is explaining how they bond, but sometimes it's not going to be totally correct. And that's what you're doing when you're balancing the equation. You're showing, oh, they actually had double or triple molecules, not just singles. Okay? So now we're using exactly what I did yesterday. How many magnesiums is this? 2. How many oxygens is this? 2. Does that equal the left side? Yes or no? No. Which element does not match now? Magnesium. How do I make him match? Double him. Okay? The only way to get better at this is to work them. So don't start panicking and feeling like you don't know what you're doing. We're going to break it down step by step, and you have to keep practicing and keep trying. Okay? Let's try another one. What's the first step I want y'all to do? Count your atoms for each element. Who doesn't know how to do that? Yeah, everybody knows how to do that. That's what we did yesterday. Okay? So how many do I have right here? 2. How many oxygens? 2 equals. How many hydrogens? 2. How many oxygens? 1. Hydrogen on the left, hydrogen on the right. How does that look? Good. Leave them alone. Don't worry about them. Oxygen on the left, oxygen on the right. Not good. We're not equal. So I can't go over here and do anything to this little subscript Because then I would be destroying matter. I can't just say, oh, I'm going to cross that out and I'm going to put a 1. No, you can't do that. You destroyed it. But could I say, water has not 1 water, but 2 waters? Yeah, I can double the water. So if I double this, it's going to be 2 times 2 and 2 times 1. So how many hydrogens would I have? 4. How many oxygens would I have? 2. Most people don't like to do this because they're worried about messing up their hydrogen. It's okay. Because what can we do to fix him now? 2 oxygens, 2 oxygens. 4 hydrogens, 2 hydrogens. How can this be 4? Double it.
Oh, okay, so when it's behind the numbers that's behind the equal sign, when you double it, it goes to both of them, but the blank that's before both of the products, it just goes to...
Yes, the plus separates those two. Because they're saying these two are going to combine chemically and make that. That's a great question. Okay? Okay, you're going to try these two on your own. Okay, first step. Count your atoms, right? How many copper? How many chlorine? Hydrogen? Sulfur? Okay, copper has 1, copper has 1. Sulfur has 1, sulfur has, leave them alone. Hydrogen has 2. Are we balanced? Nope. You got lucky because your chlorine and your hydrogen both have 2 on the left, but 1 on the right. So I can't turn them into a 1 because I would have to subtract some. Can I get rid?
Miss Lowe,
Yes, ma'am.
I need to see Bailey Poirier in Miss Reed's office.
Okay. Are y'all following me? You with me? So I can't just get rid of these. So I have to make these double. If I put a 2 right here, how many hydrogen will I have? How many chlorine? 2. And how many do they have over here? 2, 2, 1, 1. Balanced. Okay, this one. Zinc has 1, hydrogen has 1, chlorine has 1. Does that equal 1, 2, 2? Nope, not balanced. Which element does not match? Hydrogen and chlorine. Well, you got lucky again. They're right here by each other. And how many do they both need? Double it. Zinc on the left has 1. Zinc on the right has 1. Hydrogen, 2. Hydrogen, 2. Chlorine, 2. Chlorine, 2. Balanced. Everybody's good. No questions. Okay. Okay, try those. Okay, let's try them. How many irons? 1. How many chlorines? 2. Iron. Chlorine. Iron matches. Chlorine does not. So I need a number that works with 3 and 2. What's the number that works with 3 and 2? 6. If you ever look at an equation and you're not sure which numbers to try, you always have this option. I'm going to try this subscript in front of him, and I'm going to try this subscript in front of him. Because these 2 chlorines, I need them to be equal. And I should know that 2 times 3 is the same thing as 3 times 2. Okay? So, let's see how this goes. 2 times 1. Y'all with me still? Who's confused? Okay. 2 times 3. 3 times 2. Are we balanced? No. Who doesn't match now? And how can I make that a 2? Double it. Okay? So one trick is always try his subscript there and his subscript there. Next one. 1 copper, 1, 1, 3, 1. Oh, how many? 2 nitrogen, 6 oxygen. Remember that from yesterday? That means those parentheses are doubled. Are we balanced? No. Copper's good, Ag's good, oxygen's not, nitrogen's not. Since this oxygen has this right here, I would try this nitrogen. I would fix that nitrogen first. How could I make this nitrogen match the 2? Double it. What's 2 times 1? What's 2 times 1? What's 2 times 3? I'm done? Okay, which one's AG? What does it need? 2. Y'all, this is trial and error. If it doesn't work, you erase it and you try again with a different number. Okay? How many hydrogen are here? Sulfur. Oxygen. Sodium, oxygen, hydrogen equals sodium. 1, 4, 2, 1. Are we balanced? Okay. We're not balanced. We have sulfur's good. It's the only one, huh? No, oxygen. How many oxygen do I have on the left? 5. Who's lost? Take this, make a wall. How many do I have on this side of the wall? 5. 4 and 1. How many oxygen total do I have on this side? 5. Okay? But sodium, that's who I would start with first. Because those hydrogens and oxygens are separated, you could have started with your hydrogen and oxygen. It's not a big deal. Just me personally, I want to stay away from them. I'll worry about them at the end because I have to. But right now, what's the easiest thing I could try? Look at this. Sodium has 2 on this side, but 1 right here. What could I do? Double it. Two times 1. 2 times 1. 2 times 1. 2. Now, how many hydrogen do I have all together on the left? 4. You see it? See it? On this side, I only have 2. Sodium matches, sulfur matches, oxygen doesn't, but that's okay because I need to worry about this hydrogen. How can I make this hydrogen who has 2 have 4? Double it. 2 times 2 is 4. 2 times 1 is 2. Okay, now let's check each one out. Hydrogen has 4 on the left, and how many on the right? 4. Sulfur has 1 on the left and 1 on the right. Oxygen has 6 on the left and 6 on the right. Sodium has 2 on the left and we're balanced. Okay? Everybody's cool. We'll get so much better. We will practice.